Sitting by our window, we watch as the days and nights roll by, bringing with it the snow of winter, the warmth of summer, the freshness of monsoon, the scent of spring, and the coziness of autumn. Have we ever paused to wonder how these wonderful changes that we witness occur? And when we do, what is unveiled is nothing short of a miracle in process. Like the human body, the climatic conditions of Earth also undergo yearly physical changes in a repetitive manner called seasonal changes, which is a division of the year marked by changes in weather, ecology, and hours of daylight. But how and why do seasons change? Although the reason for the existence of seasons may not be as dramatic as ancient Greek mythological symbolism of an unfortunate marriage between Persephone and Hades, it is nonetheless quite interesting. You see, the Earth rotates on an axis, tilting and spinning quite like a top. Simultaneously, it revolves around the Sun in an elliptical or oval orbit, taking one long year comprising of 365 days to make one huge round. Due to the orbit's elliptical nature and the Earth's tilting disposition, some parts at certain periods on Earth are exposed to the sun's rays and heat more directly than the others. The root cause of this phenomena is the axis, an imaginary line that divides the Earth into two poles, North Pole and South Pole, splitting the planet in the middle. The Earth's axis is tilted from perpendicular to the elliptical plane by 23.45 degrees. This tilting is what gives us the 4 seasons of the year, namely the spring, the summer, the autumn or fall, and the winter. Since the axis is tilted, different parts of the globe are oriented towards the sun at different times of the year, which is determined by the relationship between the overhead sun and the Earth. Along with the axial tilt, the two other integral components in the process of seasonal change are the Tropic of Capricorn and the Tropic of Cancer. The Tropic of Capricorn is the latitude situated at 23.5 degrees in the southern hemisphere, and the Tropic of Cancer at 23.5 degrees latitude in the northern hemisphere. After having inspected the significance of Earth's tilt, let us examine how the spinning of the top on its axis affects and changes the seasons we frequently enjoy, namely the spring equinox, the autumn equinox, the summer and the winter solstice. The revolution of the Earth along with the tilting of its axis causes the angle of the sun to be different in different periods. During the overhead sun period, when the sun is directly overhead, the Earth's surface and the sun form a 90-degree angle. The variations in the angle of overhead sun causes variations in solar radiation received at different periods. Keeping in mind the variations, we move on to equinoxes, which basically comprise of days in which day and night are of equal duration. The spring equinox occurs on March the 21st and 22nd, when the sun's rays are perpendicular to the equator. During this time, the northern hemisphere is in the spring equinox and the southern pole is in the autumn equinox, thus implying the springtime to come in the northern hemisphere and the fall time in the southern hemisphere. In this context, the angle of the sun's rays slowly decreases towards the pole. This results into the hours of the day and night to be equal in all places of the earth, with the northern and southern hemisphere receiving an equal amount of sunlight. After this day, spring commences in the northern hemisphere, resulting in longer days and shorter nights, while in the southern hemisphere it is autumn, where the days are shorter than the nights. Now we look at the two solstices that occur due to the Earth tilting on its axis and how they shape the weather in contrast to each other. The solstices are days when the sun reaches its farthest northern and southern declinations. The summer solstice occurs on the 21st or 22nd of June. On this day, the sun's rays are directly perpendicular to the Tropic of Cancer, resulting in the northern hemisphere receiving the largest amount of solar radiation, because of which the daytime in the northern hemisphere is the longest in the year, while the nighttime in the southern hemisphere is the shortest in the year. During this time, the northern hemisphere is said to be in the summer solstice, while the southern hemisphere is said to be in the winter solstice, making us experience the sweat and chills that we long for. Besides that, during this period, another peculiar phenomena occurs at the Arctic Circle, where the circle receives 24 hours of daylight, while the Antarctic Circle receives 24 hours of darkness. Thus, it is quite evident how the tilting of Earth causes variances in the temperature in the different hemispheres of North and South, including the average daily temperatures. The Earth's tilting and the variance of the angle of sun's rays is also a great driver of climate in the form of the sun's effect on our oceans. Warming oceans lead to evaporation of moisture from the sea into the atmosphere, and the warming or cooling of oceans also creates convective currents. The evaporated moisture and convective currents together cause energy to be moved around the atmosphere and oceans, creating our climatic conditions.